Okay, hey, welcome back, class. Today we're going to start off our new unit dealing with molecular structure. This unit can be broken down into 4 sections, the first being electrostatic forces, then we talk about bulk scale properties, then we hit up chemical bonding, and then finally we're going to end with molecular geometry. Today we're going to start off with our electrostatic forces and its implications for molecular structure. Like always, we have to have a clear direction of where we're going, so we're going to talk about our objective. Okay, so today's objective is to be able to identify how electrostatic forces create attractive and repulsive forces within an atom or molecule. Okay, so let's start off with what exactly is electrostatic forces. Well, in its simplest form, electrostatic forces are charged portions of either an individual atom or a molecule, and how those forces interact with each other. So one thing we want to keep in mind is that not only the type of charge, but the quantity of charge is going to affect how these atoms or how these charges interact with each other. Okay, there are 3 types of charges: a positive charge, a neutral charge, and a negative charge. The 2 extreme charges, the positive and the negative, are what's going to create the strongest electrostatic forces. The strength of the forces are determined by the quantity and type of charge. So opposite charges attract each other. For example, a positive charge is going to be attracted to a negative charge. The quantity of those charges also affect the strength of the attraction. For example, if object A has 3 positive charges and object B has 3 negative charges, the attractive forces between them is going to be very strong. But if object C has 1 negative charge and object D has 1 positive charges, yes, they're going to have attractive forces, but the one A and B, the ones that have 3 positive and 3 negative, are going to have a lot stronger forces because there's more positive and negative charges bringing those items together, those objects together. So if opposite charges attract each other, then the opposite of that, or the fact that we have 2 like charges, that's going to repel each other. So if I have 2 positive charged atoms, they're going to repel each other. So if object A has a positive charge and object B has a positive charge, those positive charges are going to repel each other. Just like with our opposite charges, the quantity also makes a difference in how strong the repellent is. If object A has 3 negative charges and object B has 3 negative charges, that repellent is going to be really strong because there's more negative charges than opposed to if there's just 1 negative charge on each object. Now that we understand this basic concept, we can talk about intra and intermolecular forces. Intermolecular forces are attractive or repulsive forces between molecules. This means these forces are typically what binds atoms to each other. Generally, these are weaker forces holding individual atoms to each other than the intramolecular forces, which are going to be holding atoms themselves together. So think about this. We can break a molecule apart, which is just multiple atoms put together, easier than we can break an atom. Okay, it creates less energy and it's just easier to break those bonds. So intermolecular forces are forces holding atoms to each other. Intramolecular forces are attractive or repulsive forces inside an individual atom. So intramolecular forces are what hold an atom together. The positive and negative charges between the nucleus and the electrons are what keep an atom stable and keeps it together. So if we have lithium has 3 protons in its nucleus, and that has 3 electrons that orbit around it because it's neutral. So those electrons are attracted to the proton. That's what holds a lithium atom together. That force, that intramolecular force, or the electrostatic forces between the protons and electrons, is what holds this lithium atom together. Okay, so this brings up some interesting questions. If opposites do attract, what stops the negatively charged electrons from joining the positively charged protons within the nucleus? Or vice versa? Well, let's first tackle why do protons not leave the nucleus? Well, yes, opposites do attract. And yes, protons are in the nucleus and electrons are outside the nucleus. Theoretically, you would think they would just attract to each other to the point which they're touching. Why is that not so? Well, first of all, protons are also attracted to neutrons. Neutrons, yes, are neutrally charged, but they also have nuclear forces holding the protons to the neutrons. Those nuclear forces are a lot shorter because they are closer together. The neutrons and the protons are really close together in that nucleus. It's going to be stronger than electrostatic forces between the protons and the electrons. So that's why the proton doesn't leave the nucleus. Well, then why does the electrons not just come on and touch the nucleus or get into the nucleus? So in our last unit, we talked about waves and electrons behaving in wave-like fashions. Einstein proved that electrons can behave both as waves and as particles. These particles, in the form of photons, orbit around the nucleus. So this is where we get our different energy levels. But we also know electrons can behave as waves. So they're not just staying in one neat orbit. They're moving, oscillating back and forth, and they're jumping from level to level. They're just moving around a lot. What stops the electrons from touching the nucleus? This again goes back to our nuclear forces and our neutrons. The electron, when it's behaving like a wave, is going to get as close as it can to the nucleus. But because the neutron also, it's neutrally charged, so it has positive and negative charges, the negative charges is going to still repel the electron, so I can't fully touch the nucleus. Those nuclear forces repel the electron, so it's going to get really close, but then it's also going to go back up to its other energy level. Or that is why the electrons don't join in with the nucleus. Okay, so that's intramolecular forces within an individual atom. Finally, let's talk about intramolecular forces within a molecule. Remember, a molecule is multiple atoms put together. In other words, we're going to talk about how the charges of individual atoms can create molecules or aid in bonding molecules. We know atoms can gain or lose electrons. That's going to make them either more positively charged or negatively charged. We remove an electron, it's going to become more positive. If we add an electron, it's going to become more negative. Okay? These charged ions, so the fact that if they lose an electron or gain an electron, they become charged particles, which are ions. These charged ions can attract oppositely charged ions and repel those are the same charge. So let's take a neutral atom of sodium and chlorine. Sodium has a tendency to release an electron or lose an electron. If sodium releases its one electron and it goes over and combines to chlorine, first, sodium is going to turn into a more positively charged ion because it lost its electron. Well, chlorine, who has a tendency to take on electrons, takes that extra electron on, making it more negative. So we have a positive sodium and a negative chlorine. Well, now we have naturally opposite charges. Those charges then are going to attract each other. So we have sodium ion and a chlorine ion. They come together because of their charges. That's going to create an attractive force. And now they make a new compound as sodium chloride, also known as table salt. So that's just an example of one with a +1 charge and a -1 charge. Let's go back to our rules about charges and talk about, like, okay, if there's multiple charges, that's going to make it stronger. So if we have an atom that loses 3 electrons, has a +3 charge, and an atom that gains 3 electrons has a -3 charge, that's going to have a stronger bond to each other than our sodium chloride, which had a +1 and a -1. So just remember, quantity of charges affect the strength of the bond. And saying all that, I feel that's enough talk about electrostatic forces and intramolecular, intra and intermolecular forces. Hope this helped you out and gave you a quick understanding about how an atom is made up and how molecules hold themselves together. We'll get more in depth with this with the next lecture. And saying that, keep up the good work and see you next time.